Hello everyone. Hope all of you are doing great. Having a great time at home. So today's topic is numbers. So we are going to start numbers today. So before starting, let's just get an idea why we study numbers and what is the terminologies or what we are going to discuss in this chapter. So what is the importance of numbers? Numbers are very important for any exam in which quantitative aptitude is coming. So numbers will going to play a major role. Around approximately 10% of the questions will be from numbers at least in your any competitive exam. So numbers is going to play a very crucial role. Plus numbers is not that much tough for those students also who are very weak in maths or who are not very strong in maths. So getting the idea of numbers or solving numbers question is not going to be that tough for all of you. So I hope this introduction is more than sufficient. So let's start the numbers. Gradually and slowly we'll try to learn what are numbers, what are the different types of numbers, what is happening there. So let's just start the topic, basic of numbers one. So we are going to discuss this numbers chapter in two classes. So this is class 1 which is going on, class 1 part 1 which is going on. So let's start. So सबसे पहले the most important term which comes to our mind when we talk about numbers is what is digit and what is number. So just tell me or just try to get the answer, what is the difference between a digit and a number. I hope most of you have got the right answer. So digit is basically, digits are the tools from which we can form infinite numbers. So digits are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 10 digits in our decimal system, in our standard base system, which is base 10, in which we do all the calculations which we have studied till now. So in that system there are 10 digits, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. After this 9 we start combining these digits, or we start making them one, or we start using two digit at a time, and then when all the two digits are exhausted, then we'll start using three digits at a time, and so on. So after 9 we are going to use 1 0 1 1 1 2 and so on. So we can say digits are the tools from which we can form infinite numbers. Digits are the numbers as well as digits also. So 1 is number as well as digit also, 2 is number as well as digit also. But 11 is a number, not a digit, because it is a combination of digits. So combination of digits is not a digit, it is a number. So if we have more than one digit, then it is called as only number. But all the digits are also called as numbers also. So 0 1 2 3 4 minus 1 minus 3 minus 12 minus 18, all of these are numbers. So we are going to study number system. In what would be the broadest classification of number system, if you can guess? Yes, most of you have got the right answer. Number system can be broadly classified into two categories. What are they? We are just getting the idea of numbers by this number tree. What is happening? So what is the broadest classification of numbers? It can be divided into two categories, two broad categories, which are real numbers and imaginary numbers. What are real numbers? Numbers which can be represented on number line or real line or x-axis on the s-plane are called as real numbers. Numbers which cannot be represented on x-axis or number line is called as imaginary numbers. Or we can say imaginary numbers are those numbers uh, in which the quantity inside the under root of which is not positive, or under root of negative quantities are called as imaginary number, and under root of positive quantities are called as your real numbers. So here we are concerned only with real numbers. We will confine our studies or our discussion only till real number, because in your exams only real number is important. So we are going to study only real numbers. We are not going to study what are imaginary number, what is root minus 1 is equal to iota or j. We are not going to study all that stuff. So imaginary number is not going to play a role in our study or in our discussion. We are going to discuss only real numbers. And real numbers are all those numbers which you have seen till date: minus 1, minus 2, root 2, root 3, 0 0.5, minus 1.5, 0, 2.3, 5 by 4, 7 by 6. All those numbers are called as real numbers, which can be represented on number line. I hope it is clear to everyone. So now we are going to study, or we are going to restrict ourselves only till real numbers. We are not going to study imaginary number, but because that is not the part of our syllabus. So again, what could be the broadest classification of real numbers? Real numbers can be broadly classified again into two categories, and these categories are rational numbers and irrational numbers. So we are just going to study what is rational and what is irrational a bit later. First, let us just classify all of them. So further, rational numbers can be classified again into two categories, fractions and integers. Fraction again can be classified into three categories. Three types of fractions are possible: proper fraction, improper fraction and mixed fraction. So what is proper fraction? Where numerator is less than denominator. What is improper fraction? Where numerator is greater than denominator. And what is mixed fraction? Quotient remainder upon divisor form is called as your mixed fraction. So these are the types of fraction which we have to study. Then comes integer. What are the different types of integer? Integer can be broadly classified into three categories: negative integer, zero and positive integer. So always remember, zero is neither positive nor negative, it is a neutral number. So it will not come under positive category or negative category, it is a neutral number. So neutral integer, or precisely you can say that. So integers can be broadly classified into three categories. What are they? Negative integer, zero and positive integers. I hope this classification of numbers is clear. What is this classification is saying? Number system can be broadly classified into two categories: real and imaginary. Imaginary is not the part of our syllabus, real is only the part of our syllabus. So we are going to confine ourselves to real numbers. What is imaginary? Root negative is called as imaginary, which is noted by I or J, not the part of our syllabus. What can be the broadest classification of real numbers? Again, it can be classified into two categories, again rational and irrational. Further, rational number are divided into two categories: fraction and integer. Fractions, three types of fractions are there: proper, improper and mixed fraction. Proper fraction where numerator is less than denominator, improper fraction where numerator is greater than denominator. And we can write improper fraction into mixed fraction as well. For example, if I divide 10 by 6, so 6 ones are 6, remainder is 4. So quotient remainder upon divisor. So quotient is 1, remainder is 4 and divisor is 6. So 1 4 by 6 is going to be our mixed fraction of 10 by 6. I hope it is clear to everyone. And again, then integer can be classified into three categories: negative, zero and positive integer. Always remember, zero is neither positive nor negative, it is a neutral number. I hope it is clear. So now let us study one by one what all these things are. So let's study digits. We have already discussed the tools from which we can form infinite number. And how many digits are there? 10 digits are there from 0 till 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All of them are digits. And from those digits we can form infinite numbers from the combination of those digits. Next comes your rational number. So what is a rational number? Rational number can be defined in two ways. First is numbers which can be represented in the form of p by q, where both p and q are integers and q is not equal to 0, are called as rational numbers. For example, 2 by 3, 7 by 9, all of these are your rational numbers which can be represented in the form of p by q, where p and q both are integers and q is not equal to 0. Why q is not equal to 0? Yes, right, because q is in the denominator, and if denominator becomes 0, then the quantity will become tending to infinite or very large quantity, which is not defined. So that's why denominator can never be equal to 0. I hope it is clear. Next definition of rational numbers. Rational numbers can be either terminating or non-terminating and repeating decimal. What does this statement say? For example, if I say that if I take an example 5 by 2. Now 5 by 2 is in p by q form, where p is 5 and q is 2. And q is not equal to 0, and both p and q are integer here. 5 and 2 both are integers. So when we divide 5 by 2, first definition is satisfied. 5 by 2 is in the form of p by q, where p and q are integers. Now second definition, is it satisfied or not? If we divide 5 by 2, what we will get? 2.5. So after decimal, it is ending at 5. 2.5 and that's over. That's it. So it is terminating at 5. So either terminating, or if non-terminating, then repeating decimals are called as rational numbers. Let's take the example of non-terminating and repeating also. You can take an example of 10 by 3. If we divide 10 by 3, what I will get? 3.333333 infinite times. So it is not terminating, or it is not ending after point, after decimal. It is going up till infinite. So this is called as non-terminating, but a particular pattern is repeating. 3.33333. So infinite times 3 is coming. So that number is also called as your rational number. So again, let us revise. What are rational numbers? There are two definitions which needs to be satisfied for a number to be called as a rational number. What are those two definitions? Numbers which can be represented in the form of p by q, where p and q are integers and q is not equal to 0. First definition, it has to be satisfied. Second definition which comes to our mind when we talk about rational numbers is either terminating decimals or non-terminating and repeating decimal. What do you mean by terminating decimal? We have taken the example of 5 by 2. If we divide 5 by 2, what we will get? 2.5. So after decimal it is terminating. So either terminating, or if it is non-terminating, then it should repeat. Some pattern should be there. So we have taken the example of 10 by 3, which comes out to be 3.3333. So some pattern is there, even though it is not terminating, but some pattern is following. What kind of pattern? After decimal, 3333 is coming infinite times. Suppose if some number is like that, 3.4343434343. So this is also a rational number, because this pattern of 4343 is repeating infinite time. Suppose if the number is like that, 3.545727272. Although 44 is not repeating, but it is starting repeating after some time. So some pattern has to be there, then only it is a rational number, otherwise it is a irrational number. So for example, the first example which we have taken in non-terminating and repeating decimal was 10 by 3. So we can write 10 by 3 as 3.3333, or whatever part is repeating, we can take bar over that part. So we can write it as 3.3 bar also. Suppose number is 3.474747. So after decimal, 47 is repeating up till infinite. So we can write that number as 3.47 के ऊपर bar. That is also the way of representing rational numbers, which are non-terminating and repeating decimal. I hope this definition is also clear to most of you. Next is irrational number. So examples of rational numbers is 4, 3 by 5, 5 by 3, and so on. So next is 4 is also a rational number, because 4 upon 1. Q here is 1. So Q can be equal to 1. Q is not equal to 0 is the only condition. So all the integers are also rational numbers. So irrational numbers, what are irrational numbers? Irrational numbers, again two definition has to be there. Numbers which can't be represented in the form of p by q, where p and q both are integer and q is not equal to 0, are called as irrational numbers. So numbers which cannot be represented in the form of p by q, where p and q, both p and q are integers and q is not equal to 0, are called as irrational. That's just the opposite of what we have studied in rational numbers. Next definition is non-terminating and non-repeating decimal. So non-terminating and non-repeating means neither they are terminating after decimal point, nor some pattern is repeating. So anything that is happening in the FZ form. For example, 3.457892378. So anything is coming after decimal. So no pattern is there after decimal. So neither terminating nor repeating decimal are called as irrational number. Examples are root 2, root 3, 1.735. Something haphazard form is happening, no pattern is there. Root 5, pi is also an irrational number. Although 22 by 7 is a rational, but pi is irrational. Why it is so? Because 22 by 7 or 3.14 is the approximate value of pi. It is not the exact value of pi. That's why. So pi's approximate value is 22 by 7. It is not the exact value of pi. Always remember this thing. So we can say this thing, that pi is going to be what? Pi is going to be irrational, but 22 by 7 or 3.14 is going to be rational. Why? Because 22 by 7 is the approximate value of pi. We do not know the exact value. That's why we have put this pi in the category of irrational numbers. I hope till here everything is clear to everyone. So numbers which can be represented in the form of p by q, where both p and q are integers, are called as rational numbers. Either terminating or non-terminating and repeating decimals are called as rational numbers. Numbers which cannot be represented in the form of p by q are called as irrational number. Non-terminating and non-repeating decimals are also called as irrational numbers. Okay, let's move further. Now next is even number. What are even number? All those natural numbers which are divisible by 2 are called as even numbers. Example 2, 4, 6, 8 and so on. So all of them are even numbers. Next is odd number. All those natural numbers which are not divisible by 2 are called as even number. 3, 5, 7, 9, 11, 13 and all of them are odd numbers. We all know this thing. Next is what are whole numbers. Whole numbers is 0 plus positive integer. So 0 and positive integer. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 and so on up till infinite. All of them are whole numbers. So in integer part, we have classified integer into three categories. What were those three categories? Negative integer, 0 and positive integer. So except for negative integers, all integers are called as whole numbers. So 0 and positive integers are called as whole numbers. I hope this is clear to most of you. So whole numbers are 0 and positive integer, or we can say except for negative integer, all integers are called as whole numbers. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 up till infinite. All of them are whole numbers. Next, what is natural numbers? Only positive integer. If we consider only positive integer, all those positive integers are called as natural numbers. So natural number starts from 1 and whole number starts from 0. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 up till infinite are called as natural number. And if this counting starts from 0, then those numbers are called as whole numbers. So can I say in whole numbers, all the natural numbers will be there, but vice versa is not true? Yes, we can say that. Whole numbers are what? 0, 1, 2, 3, 4, 5, 6. And what is natural number? 1, 2, 3, 4, 5, 6. So natural number are the subset of whole numbers. Right? Okay. Let's move further. Next is prime numbers. So what are prime numbers? Prime numbers are all those natural numbers which are having exactly two distinct factors. So all those natural numbers which are having exactly two distinct factors are called as prime numbers. Example, just think of one or two examples. Yes, 2 is the example. 2 is a prime number. It is having only two distinct factors, 1 and 2. 3 is also a prime number. It is also having two distinct factors, which is 1 and 3. 5 is also prime, 1 and 5. 7 is also prime, 1 and 7. 11 is also prime, 1 and 11, and so on. So all those natural numbers which are having exactly two distinct factors are called as prime numbers. Next comes to your mind is composite numbers. So what are composite numbers? So all those natural numbers which are having more than two distinct factors are called as composite number. Example, just give me an example. It can be 4. How many factors of 4 are there? 3 factors. Which are those? 1, 2 and 4. What are the factors? Factors are those numbers from which we can divide the given number. So if a number is 4, so the 4 can be divided by 1, 4 can be divided by 2 and 4 can be divided by 4 itself. So how many factors of 4 are there? 1, 2 and 4. So 3 factors of 4 are there. So if all those natural numbers which are having more than two distinct factors are called as composite number. So 4 is a composite number. 6 again is a composite number because how many factors of 6 are there? 1, 2, 3, 6. So 4 factors of 6 are there. So 6 is again going to be composite number. So like this we can define prime numbers and composite numbers. So there are some notes on prime numbers and composite numbers. So let's just discuss these notes very carefully because these are very important notes and very minute points from which you can get a question in the exam. So definition I hope is clear to everyone. Now move on to notes of prime numbers and composite number. First note, one is neither prime nor composite. Why it is neither prime nor composite? Because it has only one factor. Only one divides one. No other number or no other natural number divides one. So 1 is the only number which divides 1. So 1 is neither prime nor composite because for a number to be prime, it has to have exactly two distinct factors. And for a number to be termed as composite number, it has to have more than two distinct factors. And 1 is having only one factor. That's why 1 is neither prime nor composite. I hope it is clear. Next note, 2 is the only even prime number, rest all even numbers are odd. So 2 is the only even number which is prime, rest all prime numbers are odd, or we can say there is no other number, other even number except for 2 which is a prime. So what is the list of prime? 2, 3, 5 and then 7, then 11, 13, 17, 19, 23, 29, 31, 37, 41, 43 and so on. There are so many prime numbers, but 2 is the only even prime, or rest all of them are odd. Okay, next. There are 25 prime numbers in first 100 natural numbers. So there might be a question on how many prime numbers are there in first 100 natural number or like that. So answer to that question is going to be 25. So there are 25 prime numbers in first 100 natural numbers. You have to just mug up the value, so that you need not to write from starting from 2 3, then after that, then after that. So you know the answer. There are 25 prime numbers in first 100 natural number. There are 15 prime numbers in first 50 natural number. These are the facts which you should remember. Okay. Next, any prime number. How to identify whether a bigger number is prime or not? If I ask you, is 631 a prime? Is 899 a prime? So how to identify that? So there is a equation. In any prime number greater than 3 is of the form 6k plus minus 1, where k is equal to natural number. But this statement is useless as its vice versa is not true. So what does this statement means? Let's just get through by the example. So what I am saying is any prime number greater than 3 is of the form 6k plus minus 1. So how to get it? Put k is equal to 1 first. What I will get? 6 into 1 plus 1, which is 7, which is a prime number. 6 into 1 minus 1, again 5, which is a prime number. 6 into 2 plus 1, 13, which is a prime number. 6 into 2, 12 minus 1, 11, which is a prime number. Till now I am getting prime numbers only by putting different values of k. So 6 into 3 plus 1, 19, again a prime number. 6 into 3 minus 1, 17, again a prime number. But now when we put k is equal to 4, what I will get? 6 into 4 plus 1 is 25, which is not a prime number. That's why this statement is useless. Why? Because its vice versa is not true. Any prime number, it is true, any prime number greater than 3 is of the form 6k plus minus 1. But all the numbers of 6k plus minus 1 form is not prime. So if all the number is not prime, then it is going to be useless for us. I hope it is clear to everyone. So any prime number greater than 3 is of the form 6k plus minus 1, where k is equal to natural number, but this statement is useless as its vice versa is not true. I hope it is clear. Because if we put k is equal to 4, what I am getting? 25, which is not a prime number. So how now? Again, the question is there only. How to identify whether a bigger number is prime or not? To identify whether a bigger number is prime or not, we first find out the approximate square root of that number and divide the given number by all the prime numbers less than the square root obtained. If it is divisible by any of them, then it is composite. Oh, it becomes a very composite statement, a very complicated statement. So just get the idea. What this statement is trying to say, whether to find out a bigger number is prime or not. For example, let's take an example, 631. Is 631 is prime or not? We need to find out. So how to find out whether 631 is prime or not? What we will do, we will take the approximate square root of 631. So how to take the approximate square? Need not to take the exact square root, we can take the approximate square root. So what is the perfect square number which is closest to 631? Which comes to our mind is 621. So what is the square root of 6? Oh sorry, 625, not 621, my mistake. So what is the approximate square root which is closest to 631? It is 625. And what is the square root of 625? It is 25. So we will, so what is the square root of 631? It should be 25 point something, because 631 is greater than 625 and the square root of 625 is 25. So square root of 631 is going to be 25 point something. So now what we need to find out? We need to find out the approximate square root of 631, which turns out to be 25 point something. Now we have to divide the given number 631 by all the prime numbers less than the square root obtained. So what is the square root obtained? It is 25. So we have to divide 631. We try to divide 631 by all the prime numbers less than square root of 631, which is 25 point something. So what are the prime numbers which are less than 25 point something? It is going to be 2, 3, 5, 7, 11, 13, 17, 19, 23. Till 23 we need to check only. So if it is divisible by any of them till 23, then it is composite number. And if it is not divisible by any of them, then it is going to be prime. It is not going to get divided by any other number after that. So what we need to do, we just have to take the approximate square root of the given number and try to divide the given number by all the prime numbers less than the square root obtained. and if it is divisible by any of them, then it is composite, otherwise it is a prime number. I hope this is clear to everyone. Let's take one more example. So 631 is not divisible by any of the prime number till 23. That's why it is a prime number. So let's take another example, 899. So what is the approximate square root of 899? It is 900 because it is close to 900. And what is the square root of 900? It is 30. So square root of 899 has to be 29 point something. So we have to divide 899 by all the prime numbers less than 29 point something. So if we divide it by all the prime numbers less than 29 point something, it is divisible by 29. When we divide 899 by 29, what is the question? 31. Because this number 899 is 29 into 31. So we can say if it is divisible by any of them, then it has to be composite number. That's why 899 is a composite number, because its factor are 1, 29, 31 and 899. I hope this definition is clear to everyone. What we have discussed, just revise it. To identify whether a bigger number is prime or not, what we need to do is we first find out the approximate square root of that number by taking a perfect square near to it. Okay, and then divide the given number by all the prime numbers less than the square root obtained. If it is divisible by any one of them also, then it is a composite number, otherwise it is a prime number. So 631 is not divisible by any of the prime numbers till 23, that's why it is a prime number. But 899 is divisible by 29, which is less than 29 point something, which is the approximate square root of 899. That's why it is a composite number. I hope this definition is clear to everyone. So 1 is neither prime nor composite, we have already discussed, because it is having only one factor, and to be number are called as a prime number, it has to contain two factors, exactly two factors. And for a number to be termed as a composite number, it must have more than two factors, more than two distinct factors. I hope it is clear. Okay, let's move further. What are co-prime numbers? So we have discussed prime, we have discussed composite number. So now next term is what is co-prime. Those natural numbers, those pair of natural numbers which have their HCF as 1 are called as co-prime numbers. HCF 1 means highest common factor, or the number which divides both of the number. Maximum of that number should be 1. So there is no common number except for the one which divides both of them. Then those numbers are called as co-prime numbers. Example 2, 3. What are the factors of 2, 3? 1 and 2. What are the factors of 3? What are the factors of 2? 1 and 2. What are the factors of 3? 1 and 3. So which is the common factor between 2, 3? 1 is the only common factor. Or we can say the highest common factor of 2 and 3 is 1. So our answer should be that 2 and 3 are the co-prime pairs. Similarly for 4 and 9. What are the factors of, or what are the numbers which divides 4? 1, 2 and 4. What are the factors of 9? 1, 3 and 9. So which factor is common between 4 and 9? It is going to be 1 only. That's why 4 and 9 is also a pair of co-prime numbers. Then comes your 4 and 5. So what are the factors of 4? It is going to be 1, 2 and 4. What are the factors of 5? It is going to be 1 and 5. So which one is the common factor between them? Only 1. So their HCF has to be 1. So 2, 3, 4, 9, 4, 5, all of them are the co-prime pairs. So for just remember one thing here. For a pair to be termed as a co-prime pair, it is not necessary that both the numbers should be prime. So here in the example of 4 and 9, both of the number are co-prime, both of the number are composite number, but still it is a co-prime pair. In case of 4 and 5, one of the number 4 is composite number and one of the number 5 is prime number, but it is a co-prime pair. In the case of 2 and 3, both the numbers are prime numbers, and again it is a co-prime pair. So it is not at all required in co-prime pairs that the number individually the number should be prime. It is not at all required. They can be prime, they can be composite, but relatively they has to be co-prime, or relatively they has to be relatively prime. Relatively prime means their HCF should be 1, or they should not have any common factor except for 1. Then those pairs are called as co-prime pairs. I hope it is clear to everyone. Okay, let's move further. Let's see divisibility rule. This is the what we have discussed till now is going to be the number tree, or the classification of numbers. What are the classifications of number which we have discussed? Numbers can be broadly classified into two categories. What are they? your real numbers and imaginary numbers. Imaginary numbers is not the part of our syllabus, so we are not going to discuss the imaginary numbers in our discussion. We are only restricted only till real numbers. Again, real numbers can be further classified into two categories. What are they? Rational numbers and irrational numbers. So what are the rational numbers? Which can be represented in the form of p by q, or which can be either terminating or non-terminating and repeating decimal. And again, irrational numbers which cannot be represented in the form of p by q, where p and q are integer and q is not equal to 0. Okay, then again, rational numbers can be further classified into two categories: fractions and integers. What are the different types of fractions? Proper, improper and mixed fraction. What are the different types of integer? Negative, zero and positive. And then we have discussed all the definitions of whole number, natural number, even number, odd number, prime number, composite numbers and co-prime numbers, and all of them. I hope till here everything is clear to everyone. So next is divisibility rule. So first topic which comes to our mind after classification is going to be divisibility rules. So there are some set of rules by which we can define a bigger number is divisible by a smaller number or not. We are going to discuss here. So let's start discussing it. So 2 की power n. What is the divisibility of 2 की power n? If last n digits of the number of the given number is divisible by 2 की power n, or n zeros are there in the end, then the number is said to be divisible by 2 की power n. For example, if we want a number to be divisible by 2, how can we say a number is divisible by 2? So any given number, if its last digit is divisible by 2, then that number is also divisible by 2, or the last digit should be either 0 also. So for example, a number is like that: 2, 3, 4, 7, 8. So last digit is 8, so this number is divisible by 2. If the number is like that: 2, 3, 5, so last digit here is 5, so that is not divisible by 2, so the number is also not divisible by 2. So need not to divide the whole number, just by last digit we can say the number is divisible by 2 or not. Next, what is 2 की power 2? What is the divisibility of 4? 4 is written as 2 की power 2, so it is also of the form 2 की power n. So whether to define a number is divisible by 4 or not, what we have to say? Last two digit, because it is 2 की power 2, so n here is 2. So if last two digit is divisible by 4, then the number is also divisible by 4. Again, an example, let's take an example. So if I say 2, 3, 4, 6, 4 is a number, whether it is divisible by 4 or not, we will divide the last two digit by 4. So last two digit here is 64, and 64 is divisible by 4, so this number is also divisible by 4. Suppose if we take a number 2, 3, 5, 7. Now last digit here is 5, 7, and 5, 7 is not divisible by 4, so this number is also not divisible by 4. I hope it is clear to everyone. Next, similarly like this, 2 की power 3. So if we want to find out whether number is not divisible or not divisible by 8, what is 8? It is 2 की power 3. So it is again of the form 2 की power n, and for a number to be divisible by 2 की power n, last n digit should be divisible by 2 की power n. So let us take an example. Suppose number is 3, 2, 4, 4, 4. So is this number divisible by 8? Is 444 divisible by 8? No. So this number is also not divisible by 8. Suppose a number is 23512. So is 512 divisible by 8? Yes. So this number is also divisible by 8. So in general, what we have to do in case of 2 की power n, if last n digits is divisible by 2 की power n of the given number, then that number is also divisible by 2 की power n, or n zeros in the end. For example, 200, is it divisible by 4? Yes, because last two digits are double zero, so it is divisible by 4. I hope it is clear to everyone. Okay. Next, 3. What is the divisibility of 3? Whether a given number is divisible by 3 or not, how to identify that? If the sum of all the digit is divisible by 3, then the number is also divisible by 3. For example, if I take number as 3, 6, 9. Suppose the number is 369. We need to find out whether this number is divisible by 3 or not. So one way is to divide it, but the other way is take sum of the digits. So what is the sum of 3 plus 6 plus 9? It is going to be 18, and 18 is divisible by 3. So if 18 is divisible by 3, if sum is divisible, sum of the digit is divisible by 3, then the number is also divisible by 3. So we can say 369 is divisible by 3. Okay. Suppose if I take number as 6, 3 and 2, is it divisible by 3? So 6 plus 3 is 9, 9 plus 2 is 11. So the sum of the digit is not divisible by 3, so the number is also not divisible by 3. So if a bigger number or a given number, if its sum of digits are divisible by 3, then the number is also divisible by 3, and if not, then the number is also not divisible by 3. Next, 9. So to find out whether a given number is divisible by 9 or not, again the same logic, sum of all the digits should be divisible by 9. If the sum is divisible by 9, then the number is also divisible by 9, otherwise not. Next, 5. What is the divisibility rule for 5? If the last digit should be either 5 or 0. So for example, if the number is 235, its last digit is 5, so the number is divisible by 5. If the number is 23500, again the last digit is 0, number is divisible by 5. So to find out whether a number is divisible by 5 or not, its last digit should be either 0 or 5. Then only it is divisible by 5, otherwise not. Next, 11. What is the divisibility of 11? Yes, most of you know the answer. Difference of sum of the digits at alternate places must be either 0 or multiple of 11, or even odd places should be either 0 or multiple of 11. For example, let's take example as 1331. Is 1331 divisible by 11 or not? How to find out? We will take the difference of sum of the digits at alternate places. So what is the difference of sum of the digits at alternate places? Number is starting from the last. It is very important, starting from the last. So 1331. So we'll start with the one last one, then 1 alternate places. So we will skip, it is 1331. We will skip 3 and then again 3. So 1 plus 3 is going to be 4, and the other alternate sum is also going to be 4. So 4 minus 4 turns out to be 0. So if that difference is 0, or it is a multiple of 11, then that number is also divisible by 11, otherwise not. We will see these type of questions in the examples also, how to find out. Okay. Next, what is the divisibility of composite number? A number is said to be divisible by a composite number if it is divisible by those pair of factors of that number which are co-prime to each other. And what are co-prime? We have already discussed, which are relatively prime, or which do not have any common factor, or whose HCF is 1. Okay, so for example, 6 is a composite number, and to find out whether a given number is divisible by 6 or not, so 6 is formed by 2 into 3. So 2 and 3 are the pair from which we can form 6. 2 into 3 will give you the 6, and 2 and 3 are the co-prime pair. So if the number is divisible by 2 and 3 both simultaneously, then the number is also divisible by 6. Okay. So a number is said to be divisible by a composite number if it is divisible by those pair of factors of that number which are co-prime to each other. So for 6, it has to be divisible by both 2 and 3. So if it is divisible by 2 as well as 3, then the number is also divisible by 6. If you want to take one more example, you can take 12. So in case of 12, 12 can be formed by 3 into 4, it can be formed by 6 into 2. But which pair we will consider, 6 or 2 or 3 or 4? We will consider 3 or 4. Why? Because 3 and 4 are co-prime pair, but 6 and 2 are not co-prime pair. We have to take that pair which is co-prime pair. So if a number is divisible by 3 and 4 simultaneously, then that number is also divisible by 12. I hope it is clear. We have to take the co-prime pair. Take one more example. Suppose 21. Whether a number is 24. Suppose whether a number is divisible by 24 or not. 24 can be obtained by 12 into 2, but it is not co-prime pair. Their HCF is 2, or common factor between them is 2. So we will not take 12 and 2. It can be formed by 6 into 4 also, but again it is not a co-prime pair because their HCF is 2 or their common factor is 2, and common factor should be 1, then only they are co-prime. And 24 can also be formed by 3 into 8. Now 3 and 8 are the co-prime pair. So if a number is simultaneously or divisible by 3 and 8 both, then it is divisible by 24 also. So for any composite number, a number is said to be divisible by composite number if it is divisible by those pair of factors of that number which are co-prime to each other. I hope it is clear to everyone. So we have discussed divisibility rules of some standard numbers. Okay, so let's begin with some example. Let's start solving some examples of whatever we have discussed till now, all the number tree and the divisibility rules. So just let's take some of the example. So question number 1 is, which of the following numbers is divisible by 4 and 5 both? So which of the number, there are 4 options, you need to find out which of the number is divisible by 4 and 5. 4 and 5, 4 or 5 are different things. Okay, so 4 and 5 means it has to be divisible by both simultaneously. It is not possible that one number is divisible by 4 but not divisible by 5. It has to be divisible by both. So let's check it by options. So let's first go for 5. Which of the number are divisible by 5? First is divisible by 5. Why? Because last digit is 5, and a number to be divisible by 5 or 5, it last digit should be either 0 or 5. So A option, C option, D option, last digit is either 5 or 0. So all of them are divisible by 5. So all of them are divisible, but option B is not divisible by 5. So we will skip option B, or option B is eliminated from here. Now we will check for divisibility of 4. So what is the divisibility of 4? 4 is 2 ki power 2. So last 2 digits should be divisible by 4. So we have to check only 3 options now. Option A, option C and option D. So in case of option A, is 85 divisible by 4? No. Because last 2 digits are not divisible by 4. So 7185 or option A is also not divisible by 4. Though it is divisible by 5, but it is not divisible by 4. So this option is also eliminated. Let's see option number C. Is 80, or the last 2 digits of option C, is divisible by 4? Yes. 420s are 80. So it is divisible by 4 and 5 as well. So this is going to be our answer. Let's check option D also. Is 50 divisible by 4? No, not. So again answer is C option. I hope it is clear to everyone. So answer here is 8180, C option. Okay. So like this we have to use the divisibility. These are the examples how to use divisibility rules. Okay, let's see one more example. Which of the following numbers is divisible by 36? Now first just tell me, is 36 a prime or a composite number? What are prime? Who are having only two distinct factors. What are composite? Which are having more than two distinct factors. So 36 is having more than two distinct factors because it is divided by 1, 2, 3, 4, 6 and many more numbers. Okay, so 36 is a composite number, and what we have discussed in the divisibility of composite number, we have to take that pair which are co-prime and whose multiplication is 36. So whether we will take 2 into 18, no, because they are not co-prime pair. 3 into 12, no, because they are not co-prime pair, common factor is 3. 4 into 9, yes, we have to take 4 into 9 because 4 and 9 are the co-prime pair and their multiplication is also 36. So if a number is divisible by 36, it has to be divisible by 4 and 9 both simultaneously. Okay, so we have to check for 4 and 9 both. So what is the divisibility of 4? Divisibility of 4, let's check first by 4. Last two digits should be divisible by 4. So option number 1 and option number 3, last two digits are not divisible by 4, because in option number 1 last two digits are 46, which is not divisible by 4, and in option number 3 last two digits are 35, which is again not divisible by 4. So option 1 and 3 are eliminated from here. Now we need to check for option 2 and 4. Both last two digits are divisible by 4. So now we have to check for option 2 and 4, the divisibility of 9. And what is the divisibility of 9? Sum of the digits should be divisible by 9. So let's take option number 2 first. What is the sum of the digits of option 2? 4 plus 4 plus 4 plus 6 is 18. So it is divisible by 9. So this number, option number 2, is divisible by 9 as well as 4. So it is divisible by 36. Let's check option 4 also. Is it divisible by 9 or not? What is the sum of the digits? It is 7 plus 2, 9 plus 3, 12. And 12 is not divisible by 9. So this number is also not divisible by 9. So answer here is, so option number 2, which is 4464, because it is divisible by 4 and 9 both. And for a number to be divisible by 36, it has to be divisible by both 4 and 9 simultaneously. I hope it is clear to everyone. Okay, let's take one more example before ending this session. What least whole number should be added to 1, 2, 3, 4, 5 to make it a multiple of 9? So we want to make 1, 2, 3, 4, 5 a multiple of 9. So what is the divisibility rule of 9 we have discussed? We have discussed a number is said to be divisible by 9 only if the sum of all the digits is divisible by 9. So here what is the sum of all the digits? 1 plus 2 plus 3 plus 4 plus 5 is going to be the sum of all the digits. So what is 1 plus 2 plus 3 plus 4 plus 5? It is going to be 1 plus 2 3, 3 plus 3 6, 6 plus 4 10, 10 plus 5 is 15. So 15 is going to be the sum. Now for a number to be divisible by 9, that sum should be divisible by 9, and what least number should be added to 15 to make it divisible by 9. So after 15, which is the multiple, is the closest multiple of 9? It is 18. 9 to the 18. So if we add 3 in 15, what we will get? 18. Sum will become 18, and if sum will become 18, then the number is divisible by 9. I hope it is clear to everyone. 1, 2, 3, 4, 5. The sum of all the digits is 15, and it to be divisible by 9, sum of the digits should be divisible by 9. So what is the next multiple of 9 after 15? It is 18. And what should be added to 15 to make it 18? 3 should be added. So if we add 3, number is divisible by 9. If we add 3 to 1, 2, 3, 4, 5, it will become divisible by 9. Okay. Next question. What least whole number should be added to 32145 to make it a multiple of 11? Okay. So what least number should be added to 32145 to make it a multiple of 11? I am giving this question to you for homework. Just try to solve this question, and we will start our discussion from this question only in the next part of this session. Okay. Thank you.